So what we're going to do tonight is we're going to take a look at the content that's in chapter 9 and 10. Most of the content is actually in chapter 9. Chapter 10 is sort of follows from it. Chapter 10 does, though, cover the string class very nicely in much more detail than we've already covered in an earlier chapter. So let's just talk about what we're doing here. What we're going to be doing now is something totally different with Java. Up to now, we've been working with primitive values. We've been working with ints and doubles and chars. Sometimes we use string, which is not a primitive value. A string is an array, is an object type, since it starts with a capital S, as you know. Well, and we also learned how to create an array, a collection of objects, or an array list. And what we're going to do now is we're going to define an entirely new data type that fits the application that we're working on. That's what object-oriented programming allows you to do. For example, if you were working for Amtrak, the railroad outfit, you would no doubt make boxcar objects. You would create a boxcar class, and you would then create boxcar objects, put them together to make a train. If you worked for the zoo, you would probably make an animal class so that you could make animal objects, and then you could keep track of all the information you needed to keep track about your animals in the zoo. It's called object-oriented programming. It's a little different from procedural programming, although it includes procedural elements. Like what we've done in the past, and I guess we'll still do it again today, is procedural programming. Programs just have a start and a finish. They run through all the instructions in order one by one, and then when they get to the end, that's it, the program is over. And for many years, that's what all programming was like. Object-oriented programming allowed an entirely new way of looking at programming, where we create objects to model the data that we're working on. And that actually is what led to the development of Windows and other GUI programs, like what you would see in a Macintosh environment. I guess the Mac, Apple actually was in the forefront of the object-oriented movement, really. But when you're working with Windows, you're working with objects. These folders over here, they're objects. When you're playing a game, the sprites that are in your game are objects. So what we're going to do is we're going to introduce it here. And the example that I've made up here, we're going to look at a vehicle class that we can use to keep information about vehicles. So what we're going to do is we're going to make the assumption that we're working at an automobile dealership. It's going to be a Nissan dealership. And so what would you want to keep? What information would you want to store about a vehicle that you're selling at your dealership? Well, if it's a Nissan dealership, I don't need to have a make property. These are called the properties or attributes of a vehicle. What we want to store about a vehicle is the model, the price, and the year. Now, in fact, in reality, you would store many more attributes than this about a vehicle. You could have, for example, the car, information about the engine. You would have the color inside, the color outside, right? All sorts of information, more attributes. But we need to keep it simple, and I also need to conserve screen space here. So let's imagine that all we want to know about a vehicle is the model, the price, and the year. I'm making these private because that protects them from accidentally being changed, and it also it encapsulates the data so that it can only be accessed by methods that we write in this class. And that's a good procedure to practice. You should always follow that. Okay, now that just defines, as you can see, we don't have a main method here, right? It's just, this is a data class, a different type of class. Now we are going to create what's called a constructor. when you define a class, you need to define one or more constructors. And Eclipse makes it easy. Here's all I have to do. Select source, generate constructor using fields. I get a dialog box with the attributes already selected. All I have to do is hit generate, and there's my constructor. Now this is what we would call a parameterized constructor. As you can see, it has the model, price, and year. It has a call to super. That's actually, you won't see that in your textbook, but that's a reference to the fact that all classes in Java inherit from the capital O object class, and you'll learn more about that later. But this is where we're going to assign values to a new car. When we write a main program in a few moments, we'll need to create vehicles. And to create a vehicle, we have to use the constructor. And this is how we would do it. You know, we can also, we have to be able to access these attributes. In order to do that, we need setters and getters. So on the menu, I'm going to go with source, generate getters and setters. Now, once again, I get a dialog box. And if I select the checkboxes, that'll actually give me a getter and a setter for every attribute. Let me see if I expand them here. I get a setter and a getter for both. Now, maybe you don't want all of those. And in fact, let's see. We can't change the model, so you don't really want that. I can change the price, though. I can't change the model year, so I guess I don't need that. Oh, I don't need this setter. I do need the getter. I might want to retrieve the year. Okay, so let's say that that's what I want to go with. Watch what happens when I hit generate. This writes all this code for me. Generated all 4 methods that I requested. And no syntax errors. That's the best part about it. Let Eclipse help you when you create your classes. You know, I want you to see what we've got here. And if you notice our attributes are the properties of a vehicle. We have a price attribute. Well, look at the getter for that. It's get price with a capital P. That's the standard notation that's used for getters. And you notice it's going to return the right type. It's going to return the price. So that's all the getter does, is return the price. But you might want to change the price. Well, if you do, you have to give it a value. You have to have a parameter so that you can modify the price to the new price value. And as you can see, we also have a getter for the model and a getter for the year. Any question about these? Now, what are these for? The getters allow you to retrieve the private data. The setters allow you to change the value of the private attribute. Now, there's pretty much always one more very special method that we want, and that's called the toString method, which I can also generate through Eclipse. I'm going to generate the toString method. Once again, I get a dialog box, and I'm just going to accept the defaults. It shows the checked off attributes here. So I'm going to hit generate. And here's the toString method. Now, you'll notice it says @override. That's because we're actually overriding the toString method that we get by default from the capital O object class. But more about that later. So what this toString method does, it's going to return a string, as you can see. So what we have to do is we develop a string, and we can do this any way we want. This is the default that you get from the source menu. But I always like to modify it a little bit. Like we don't really need some of this information, so I'm going to take some of it away. Just have to have a string. So we'll make something like that. I really could leave that, but I'm going to take that out as well. And for the price, I'd like to format it and make it look like currency. So to do that, on page 372, pardon me, 392 in chapter 10, you will see there some information about the string class and its format method. So I'm going to try it, the format method, and what I want to do is I want to format with a $sign and 2 decimal places and make it look like currency. So I'm going to go with %, comma, 0.2F. And by putting the comma 0.2, that will show the thousands with the comma separator for every 3 digits in the price, and the 0.2F will show it with 2 decimal places. Now, we may not need that. As a rule, you don't see the pennies when you're looking at a price of a vehicle on a website. And then we could finish the format method like that. So that's a string format method. Whenever you want to use string format, you have to have a format string here that specifies how you want to format. And it's like printf, right? System.out.printf. It's the same concept as far as the formatting. And then what variable you want to format here. Now, we don't really need to specify the word year because it's obviously going to be a year. And we don't need these square brackets, so I'll take those out too. So I've modified it, but what we're going to do is we're going to return that string, and that will allow us to see what is actually in the object that we're going to create, the vehicle that we create. We'll show you how to use that. Okay, so I'm going to save that as my class definition. But before I carry on, I want to ask you if you have any questions about that. Any questions about that? Any questions at all, folks?
No.
Okay. Okay, Madhu. Any questions?
I'm
What
good.
we're doing. Let me just repeat what we're doing here. We're we're creating a class called vehicle, which will allow us to make vehicle objects in a program. What we want to know about the vehicle objects is pretty rudimentary. Just these 3 pieces of information. We call those attributes or properties. Sometimes they're also called fields. And when we want to create a new object in a program, we have to use a constructor. This is the parameterized constructor, which will allow us to specify values for the model, price, and year when we make a new vehicle. And then we have some setters and getters that we can use to modify or retrieve the data because we made that data private. And then we have a toString method, which will allow us to see what was actually created when we created the object. Okay, so let's say that that's our basic vehicle class. Now, definitely this is a very rudimentary class. Now let's take a look at how we might use that in a program. I've got a program prepared here for that. Okay, we've got a class here called Make You Huge. I guess you know what that's all about. It is a Nissan dealership. And let's create some vehicles. As you can see here, we're creating, looks like, what about, I haven't duplicated anything there. So we're creating 6 vehicles. I just called them V1, V2, and V3, etc. And here's where we run the constructor. This line here is running that constructor. And the constructor required the name of the model, the price, and the year. Okay, so this is how you create your objects. We've got a new data type called vehicle. If you were going to create an integer, you would put int there, right? Well, vehicle is a new data type for us. We've learned about arrays in chapter 7. Well, we can make an array of vehicles. Notice the square bracket notation. That lets you know that this is going to be an array. I've decided to call it in stock, and I'm using the array initializer syntax to put our 6 vehicles inside the braces. So that makes an array in stock. Now, I'm actually not going to use that. Instead, I'm going to create an array list from that. So here's probably the most important thing that we wanted you to know about chapter 11, and that is how to create an array list from an array. An array list has to be an object type. Well, vehicle is going to be an object type. We're going to call our array list inventory, and we run the array list constructor. And here's the way we can create the array list from the array. We have to use the capital A arrays class and its asList method to create the array list. So that makes the array list. Now that I've got the array list made, I wanted to demonstrate how we could add some more vehicles by using the add method. We've got the add method that we could use to add more vehicles. This will add them on to the end of the array list. But look I'm not using any named objects here. We're doing this anonymously by running this constructor embedded inside the add method. And that's not unusual. That's often done because I'm not going to actually use these V1, V2, etc. I'm not going to use those names in this program because we're going to use the list. And you can create objects anonymously just by running the constructor like this. Now, how can we show them? How can we see what we've created? Well, a good way is to use an enhanced for loop where you specify that we're going to be looking at vehicles. We're going to let each individual vehicle be a variable V in our inventory array list. And I'm just going to systemout.print line V. Now, in fact, what that does, that actually runs the v.toString method. And I could be explicit and put that in there, but you don't have to. If you take it out the toString and just put the name of the object, that will run the toString method by default. So that's a nice shortcut that is available to you in Java. Okay, now I'm just going to come into this part here for the time being. Source, add block comment, just how we can have the program ignore that for the time being. So I'm going to run this just to show you what sort of output we can get from that toString method. Okay, there's the output. There's the output that we got from this loop. Any question about that? You notice I do have sort of a currency format here. Got the commas in the thousands and so on by using.
What does the new vehicle thingy do?
Say that again.
The new vehicle?
Right up here.
I notice you have one in front of every one of them. Is it necessary?
Could you say that a little louder?
Yeah. Is it necessary?
Is what necessary?
The new vehicle.
Right here? Is that what you mean right here?
Uh-huh.
Or down here? Yeah, whenever you want to create an object, whenever you want to create a vehicle, you have to run the constructor.
Uh-huh.
Yeah, and to run the constructor, that's what the new keyword is all about.
Oh, okay.
You know how when we create a scanner,
mm-hmm.
what we say was scanner input equals new scanner? That's running the constructor of the scanner class.
Oh.
Yeah.
Okay.
So we're running the constructor of the vehicle class with new. And that's what you need to do to create a new object of type vehicle. So that's what we've done in this particular program is we've created our own data type called vehicle by defining the vehicle class. The vehicle class doesn't have a main method. You could put a main method in it, but typically that's not done. Typically what you want to do is simply use your class definition to specify the attributes and methods in the class. So, any more questions about this one? As you can see, it just went through the entire list and it ran the toString method for each and every object in our array list. No questions? Okay. Well, I'm going to bring back the part that I commented out here.
I had a quick question.
Yeah, go ahead.
So, so like this the make you huge main method. So that's basically like before when we learned about calling, like calling methods. This is like the main method, and then the vehicle.java is like the constructor. So you're calculating everything in that other class, right?
This is just the vehicle class is the definition of what a vehicle object will look like. That's what you're doing with this class. Yeah, this class doesn't run. This has to just creates a new data type called vehicle. But it's a complex data type, an object type. And objects have attributes. I decided on these three. And objects also have methods, with these. I mean, we could certainly add more, but this is I guess you could say it's a basic vehicle class.
Okay.
Sure if that answered your question. If not, ask again.
No, I got it.
Okay. All right. Yeah, so this defined the vehicle. And then we use the vehicle class here to create some vehicle objects. And I wanted to show you different ways it can be done. We have to use the constructor to create a new vehicle. And when we do, we have to think about the constructor itself. And by the way, a very interesting thing that you can do in Eclipse is if you forget what the constructor was like, you can drag it down. See if I can do that here. Yeah, look at actually, you can have them side by side like this, open multiple windows. Actually, I prefer the other way around. Open up vehicle again. I like to put it underneath. Come on. Oh. That's weird. Give me. There it is. So this way you can move between the two classes in the one window. That can be helpful because sometimes you forget, well, what was that constructor? What was in that constructor again? So you can come back here and review it here so that you can specify, oh, I need the model followed by the price, followed by the year, which is what we got here. Okay. Now, what I wanted to do here, I'll just close that one and come back. I wanted to bring this code back. Source, remove block comment. And what we're going to do is we're going to show you other things that you can do with these objects. Once we've got the objects, we're going to run a method called reduce price. It's a void method, as you can tell by the way we're running it. We're not catching any return value, so that lets us know that that's a void method. And what I'm going to do is I'm going to pass to that method our inventory array list. So we're going to give it two arguments, the array list and a number. And what we're planning to do here is we're going to reduce the 2018 models by 10%. That's what this method is going to do. So let's take a look at that method. Here's the actual method definition, and it follows the main method, right? That's the end of the main method right there. And you can see it's public static void. I called it reduce price. And whenever you write a method, you have to specify the type for the parameters. So list is going to be an array list of vehicles. And then we're going to give it a percentage for reducing the price of the 2018 models. Now, I only wanted to do it on the 2018 models. So once again, I'm going to loop through the list with an enhanced for loop. And I'm going to, if I find a 2018 vehicle, which I can do with this if statement, then I'm going to set the price to the current price. Well, to get the current price, I'd have to use the get price method and multiply it by 1 minus the percent divided by 100. So that should reduce it by 10%. 1 minus percent divided by 100 will work out to be 0.90, right?
But you passed 10.
Say again?
But you passed 10. Wouldn't that be -9 divided by 100?
When I ran it up here, I gave it 10. Would it be what? -9? It's going to turn into.
Oh, no, you divide first, yeah.
That's going to return into 0.90, right?
Uh-huh.
1 minus 0.10. That's going to turn into 0.90. So that the new price will be 0.90 of the old price.
Yeah.
Okay. So After running that method, we'll, oh, look, it messed up my formatting terribly here. I'm going to fix that. I don't like the way this is set up. This is using C-style braces, very bad. So what I'm going to do is source, format, it'll fix it all up in the Java way. You should do that before you submit your assignments, folks, okay?
Mm-hmm.
If your indentation and so on gets all messed up, use source format. So after the price reduction, we're going to print out again using the an enhanced for loop, and I'm only going to show though the 2018 vehicles. So I'm using the get year to access only vehicles that are 2018. So I'm going to run this again, and we'll get 2 bits of output this time. Here's all the inventory with no reduction. That's from the first enhanced for loop. And here we have it, as you can see, for the just the 2018 vehicles. And if you look at the prices, they are all reduced by 10%. Like, look at that Leaf. There's the 2018 Leaf. It was 23,000. Well, it's now down to 20,700 after the reduction. This didn't work out very well. I thought I would jazz it up a little bit by adding a reduced, but that did not work out real well. I'd have to rethink that. What I did was I just added on a string to the what we print out. That runs the toString method, and then we're appending onto the toString method a string here. Might be better with just one tab. Tab is always a little dangerous because it depends on the width of what you're printing out before it. Let me just run that again. No, it's still not that great. I'd probably take that out. But I hope you get the idea of some of the cool things that we can do. Once we've created an object and we've got those methods, the getters, we can use those getters to do things like, in this case, reduce the prices. Maybe we want to reduce the prices of only certain models. If that's the case, all we have to do is modify this, right?
Mm-hmm.
Yeah, just modify this.
models.
Yeah, we could say, let's see, maybe we want to reduce the centers, so we could say, and v dot, I do have a get model. By the way, notice how I'm letting Eclipse help me. I suggest that when you're starting out, the get model. Now I want to just reduce the centers. So you might think I would say equals centra inside quotes. That's not right. It's not right to do that because it's a string. And what you have to say is dot equals for strings. If you want to test the value of strings, you have to use the equals method. And then we would put center here inside quotes. So that's how we could reduce only the 2018 centers. I don't know if we have any. Yeah, we have just one center. So let's see, that should only reduce that one vehicle then. Or only display that one vehicle here. I actually should have done that in here, shouldn't I? Right? If I wanted to make sure I only reduce the centers, I should have done that right here. I put this in the wrong place. What we'll do here, I'll just cut that out of there. Cut that and paste it in here. Definitely have that in the wrong place. That's where it should be. Except we got too much copied. Okay, so that should only, oh boy, I lost some other stuff up here. Fix that up. Okay, so this should only reduce that one center. Let's try that, see if that works okay. Yeah,
That's same.
yeah, it was reduced from from 16,000 down to 14.4. So once you've created objects, then you can work with the objects. It just opens up a whole world of possibilities that you can do with your program. Now, ideally, what would obviously be done in a case like this at a car dealership, all of this information would be stored in a database. You would store the objects in a database, and then you could access the database and change the prices, etc. But the whole idea here was to get the concept of how you define a class. If you want to define a class, you can do it to model the application that you're working on. For example, let's just try another one. But before we move on, I just want to make sure that that you're okay with why this works the way it does. Any questions about this one?
Can you briefly go over the how you made all the class with the Java?
How you what?
How you like created different stuff with the source?
A new class?
Yeah.
Yeah. Okay. Yeah. Exactly. I will. Any questions about this one before we carry on, though? Okay. Not hearing anything. I'm going to make a new class. Let's say you want to program a game.
Mm-hmm.
Well, if you're programming a game, you're probably going to need some sprites. Those things, I know that you folks probably are going to be up into the wee hours in the morning playing video games after this, aren't you?
Maybe.
Well, when you're playing a video game, like say, for example, if you're playing one of those first-person shooter games, you in the game are a sprite. Your avatar, your object in the game is what's called a sprite, and all the things that participate in the game program are sprites. They're objects called sprites. So the the people that you're shooting at, for example, are also sprites. So what would we want to know about some object in a game, a sprite in a game? Well, probably we want to know the name of the sprite. Probably we would want to know, I'm thinking that first person shooter game here, we probably want to keep track of the health, right?
Mm-hmm.
We probably want to keep track of the ammo, how much ammo. We would have to keep track of what weapon is currently being carried. Lots of different things that we would have to keep track of, obviously. But let's say we just went with these for a starter. And by the way, that's the way you should develop a sprite. It's simple, get it working. Want more complexity, add more attributes, and develop it from there. Okay, so let's say we go with this for a shooter game sprite. Well, now I'm going to go with source. I want to generate that constructor using fields. They'll all be checked automatically. You just leave it like that and hit generate. There's your constructor. We can use this in the main method of a executable program to create sprites. Now you might want all the getters and setters. Let's say you want the setters and getters for everything. You can make them in a jiffy just with source, generate getters and setters, check them all, and that'll give you 6 methods without writing any code yourself. There they are. Got a getter and a setter for each attribute. Then you would want to get a toString method to report on the status of a sprite in your game. So we would generate the toString. They're all selected, so that's good. Now, if you just leave it this like that, you can see it outputs the word sprite, which you probably wouldn't want. It also puts the attributes inside square brackets. So typically, you want to modify that and to be something like this. Just want the name. Attribute. Don't want. You might want the word health, I guess. Health equals. I don't know if you want equals. Maybe just health. And probably ammo is not too bad, but we definitely don't want these square brackets. So we could leave it like that maybe. Okay, let's get rid of some of this real estate here. So there we have a very, very simple class that could define a sprite in a game. So we could then make some sprites in an executable. Let's try it. Now we need a new class. This one is going to have a main method. We'll call it game. Give it a main method. And let's create a couple of sprites. So we would do that. So sprite's a new data type. Instead of like int or double or string, we can just use sprite now. Okay, so we could go with hero equals new sprite. Help me out here. I don't play these shoot 'em up games anymore. What's the name of a hero in one of these games? Anybody? No?
Usually they don't have names.
Say what?
Soap.
Soap?
Yeah.
As in stuff you clean yourself with?
Yeah.
Okay. All right. And let's say the initial health is 5 and maybe the initial ammo is 6.
Mm-hmm.
Okay. So as you can see, Eclipse is not complaining. It is giving us a little nag here because we haven't used it yet. But there we have one sprite created. Now we could create another one. We could create an enemy, villain, or whatever you want to call it. How about a villain name? Anybody? No villain names from any games?
Reaper.
Reaper? Okay. And let's say maybe the Reaper's got lots of ammo. Or lots of health and lots of ammo. We'll go with 12 and 12. Okay. So now what we could do is we could do something kind of weird. It's not going to be much of a game, but what we could do is we could maybe add something to the sprite class. Why don't we go back to the sprite class for a minute? And obviously, if this is a first-person shooter game, we need a shoot method, right? We need a shoot. We need a shoot method in here, so we can add that anywhere we want. I'm going to put it right after the constructor here. So this would be again public. You notice that we don't need the keyword static when we're making methods inside of a class. Do that. We need the keyword static if we want to use them in a main method, but we're not doing that here. We're just defining a class. Okay, so let's say, why don't we make this return type Boolean? Public Boolean shoot. And what we have to do is return a Boolean, and maybe what we can do is, why don't we generate a random number? Let's generate a random number, and we could assume, for example, that if the random number is 0, the shot is a miss. If the random number is a 1, it's a hit. So let's try that. So int hit equals,
Math dot random.
yeah, cast it as an integer, math dot random, and we would multiply that by 2. And that's going to give us a value of either 0 or 1.
Mm-hmm.
We'll never get a 2. So that's good. And what we could do is we could
If
return, right? Yeah, we use an if. We could get kind of fancy and use the conditional operator. We could say return hit equals 0. Return. I'm not sure if this is going to like this inside the if here. We could say return true. Oh no, that's going to be false. Make that one false. So that's a miss. And then for the false, we'll say return true. I have a feeling that Eclipse is not going to like this though. Yeah, because it's conditional whether it returns anything, right? It might not. This method isn't explicitly returning a Boolean. So what we need is we need to create the Boolean here. We have to say Boolean result or whatever without giving it a value. And then here we'd have to say result equals false. And here result equals true. And then we would return result. Something not right here. Oh, I'm using Python syntax for false and true. No capitalization. My bad. Still doesn't like it. I thought that would be all right now. Oh, I don't need the return. What the heck is wrong with that? Hit equals 0. I put them inside parentheses. You shouldn't really need to do that. Okay, I guess this wasn't a good idea. So what we'll do is we'll break it up into a different else box. Okay. Eclipse likes it now. All right. That was a struggle. It shouldn't have been that hard. Okay, we got that saved. So now we could go back to the game and we could simulate, I guess, shooting by creating a loop here. So for example, we could run a for loop multiple times here. We could say, oh, maybe a while loop would be even better. So we could say while hero dot get health is greater than 0. We could run the shoot method. Hero dot shoot. And okay, so that's going to run the shoot method here. So I guess what we want, instead of returning the result here, what we also want to do inside this method, since it
Health and ammo.
returns a Boolean, but back here, what we would want to do here is we want to say Boolean. We want to catch that Boolean, right? Boolean, let's call it sh for shot, equals hero.shoot. And then what we could do is we could say if sh is true, and by the way, that's all we have to do for if sh is true, right? You don't have to say if sh equals true, that's redundant.
Mm.
If sh, then what we would do is sh dot, pardon me, hero dot, I think we have a setter for the health. We'll have to set the health to its current value minus 1. So we'll just reduce the health by 1. Now, this is kind of silly because it looks like the hero is shooting at us. Right? So we obviously need some work here, but we could instead have the hero be shooting at the Reaper. So what we could do is here, I suppose we
Change
could
the enemy.
just make it enemy, right?
Mm-hmm.
And we should change this to enemy too.
You want to get the health to enemy as well?
Yeah, we could, I guess. We could. The thing about this is it's never ending.
True, true.
I suppose what we could do here is we could just say
Like shot missed or something. Yep.
miss them or whatever. Maybe it's a female, I don't know. So this should run as well as long as the enemy health is greater than 0. So hopefully we should get the enemy's health down to 0 here. Let's see what happens if we run this. I'm not sure if we got any logic errors. Just did this off the top of my head because of your question. So let's see what happens.
That is unlucky.
Looks like I got an endless loop here. Well, I set his health to 12, which is a little high, but I might have an endless loop. What I should be doing is reporting the health too, right? So
No, you have the hero's health, not the enemy's health.
Right, exactly. Very good. Okay. I will just simplify this a little bit. I'm going to reduce his health to 5, so it won't take so long to run. Okay, all these shots missed, and once it got down to 0, he's dead. So I suppose we could add on to this that we could report
Shot here, like after the if statement.
Yeah. So we could add it right here. So system dot print enemy dot get health.
Oh, some lucky shots.
Yeah, got pretty lucky there. So, I mean, obviously it's ridiculously simplistic for a game, but it gives you the idea of how these games are created by using sprites and objects. It's object-oriented programming.
Mm-hmm.
Any other questions about this one? We could obviously add all kinds of methods in here. We could add more attributes, like what weapon is being carried, etc. We could actually make a weapon class, right?
Mm-hmm.
We can make a weapon class and then give the sprite a weapon object to work with. Yeah, so like maybe one of the attributes would be the weapon. So we would say private weapon, which is a class type, so we would capitalize it. Something like that. And unfortunately, that's going to give us an error message because we don't have a weapon class. But if we were to make a weapon class, then we could do this. Okay. Well, that's all I wanted to cover tonight is how you can use Eclipse to help you make class definitions, and then how you can use those class definitions in a main executable program to work with your objects. Any questions about that?
So on the last part of the class, there's like the get to string. How do you decide what's like needed and what's not needed?
Yeah, well, that is a big problem. That's a very big problem. That's covered somewhat in chapter 10, where where they you have to make a decision about is the object that you're thinking about that's needed in the game, or is the attribute that you need, is it an attribute, or is it actually another object, which it might be, like in the case of the weapon, right? And that is the it takes a lot of preparation, a lot of planning.
Yeah, I'm a little behind the reading, so.
Well, that's okay. Any other questions about this one? Yeah, we could make a weapon. We could make a weapon class and add it on here. What the heck? Let's do it. It won't take too long. We can make a simple weapon. So again, we'll make a new class. Like all class names, we start with a capital letter. Not going to have a main method. This is going to be a data class. What would we want to know about a weapon? Well, we'd have to know what the name was.
Another class.
I don't know what else.
Like damage.
In a game, you'd probably have like the lethality or something.
Yeah.
Whether one hit was enough to kill or not. So I suppose you could maybe make that an integer. I'm not sure. Private int lethality. Maybe we could just call it lethal. And we could leave it at that, perhaps.
Mm-hmm.
And then you'd make your constructor, source, generate constructor using fields. They're checked off by default. Let's go for that and hit generate. I wish I could put a blank line in here, but it doesn't always do that. So this will allow us to create a weapon. Now, on the weapon, we probably want we probably want getters and setters, because the weapon that's being carried by a player could change, right?
Mm-hmm.
Throw a weapon away and get a new weapon. So I guess we probably need getters and setters. So we go source, generate getters and setters. Check them both off. Done. Done, just like that. And if we wanted to see what weapon was being carried by an individual, I guess we'd have to have a toString. Just go for the defaults, then modify it. I suppose you could use the weapon string in there, but maybe just, oh, you want to do that. maybe have sex. Maybe take this out, weapon, plus name, lethality, maybe. And take away this. Probably that'd be all you'd need. Save that. I always like to get rid of the extra real estate here. Okay, so now we've got a weapon class defined, and we should be able to refer to it then in our sprite class. So I'll go back to the sprite class. This should now not generate an error message. It does indicate that we haven't used it. I would probably want to recreate the constructor at this point. I could type it in. I could put here, comma, weapon, but much easier. Let Eclipse do it for you. I'm just going to erase this and create the constructor all over again. And hit generate. Okay. There it is. I got my weapon. Now, actually, when we make the weapon, you might want to run the constructor for the weapon here. So you might want to say a little bit more about the weapon. Maybe that's okay the way it is. Maybe that's okay. But then in the game, just save that. In the game program, now obviously it doesn't match, right? So what we need here is a weapon.
But shouldn't it be before 6 since the order in your class?
Let's see where it was. Before it, exactly. So back in the game, we don't want it there. We want it right here. And then right here, we could run the constructor. New weapon. And then we could decide on what it was. Maybe it's an RPG. With the lethality of, now you'd have to decide on what maximum lethality was, maybe 10. Just like that, you can add a weapon.
Oh, a class inside another class.
Yeah. Now I did it anonymously. I didn't actually create a weapon object with a name. I did it anonymously here. We could have created a weapon. We could create our weapons here if we wanted, right? We could make a bunch of weapons here and then just add them by name. It might be a better way. So we can maybe try doing something similar to that for the next one. I'll just copy it into here. And we'll try another weapon. Maybe a blast here or something, whatever that is. Sounds lethal, so we'll also set it at 10. And as you can see, we've made some changes here. As soon as I save that, that'll go away. So now when we shoot, we want to know which weapon is being shot, right? So we'd have to modify our shoot method. It gets complex. It gets complex when you're coding games. That's why it takes dozens of people to make these games. If you look at the credits for the video games that you play, you'll see dozens of people are involved. It might be 1 or 2 people might be totally assigned to the hero sprite, the sprite that represents you in the game. And that might be all they do. And some people are going to be responsible for the storyline. Some people are going to be responsible for the environment, what's in the environment. But that's how it gets started. Okay, well, we're over time, I guess now, just out of time. I hope that worked for you. I think this is being recorded. So,
yeah, it says record on the top left.
Pardon me?
It says record on the top left.
Good. Excellent. Excellent. So what we'll do is I'll put this up on YouTube so you can look at it at your leisure. And I'll also put it in my courses. And where I'm putting these in my courses is in, let's see if I can show you here. I'm putting them in the links and resources. So in here. Okay, I'll put the videos in there. There's the one on chapter 6. Unfortunately, the chapter 7, 11 one did not take, but I'll add the new one here at the top. Okay, so that's all I wanted to do. Any more questions, folks? If not, we'll sign off. All good?
Yep.
Okay. Keep in touch. If you're having trouble, remember the secret. Zip your project, attach it to an email. I'll take a look at it and get back to you. And if you're having severe trouble and need lots of help, I could connect with you one-on-one like this with this Zoom program. And I'd be happy to do that when I'm in my office on Tuesday, Wednesdays, and Thursdays between 9:30 and 2:30 p.m. Except Thursday, I think I go home at 1:30. But I could connect with you from home and share my screen, and also you can share your screen. And it's a great way to get some quick help. Okay, we're done. Signing off now. Brad out.